Okay, good evening, everyone. My name is Anderson Bani, and I'll be taking you through the Electrical Automation Foundational class, the theoretical class, as you can call it. Let me move to. So, um, we'll be considering. Make it full screen. Full screen. Full screen. Okay, so we'll be considering um different parts of the study, but although we might not complete everything today, we will be starting with the introduction, introduction to automation engineering. Then we'll be going to control system basics, relay logic versus PLC, modern control system, then components of automated system, then the symbols used in control circuit, and then design a simple circuit, practical application of automation, benefits and challenges of an automated system. Then the conclusion, then the question and answer. So at the end of the session, you can drop your questions in the group chat where this video will be posted. So introduction to automation engineering. So automation engineering is the use of methods for controlling machineries, particularly electrical components. So basically, rather than using manual processes, rather than lifting a plate from this point to the other point using your hand or using manual labor, you are using series of components, electrical components, to carry out that particular task. So before the invention of electrical devices for automation, many repetitive tasks in factories were manned by humans. Like I said earlier, before the advent of automation, many tasks were manually carried out by manually carried out in time past. But after the advent of the automated systems, most of those tasks are now unmanned. So it now increased the accuracy of those tasks. It also improved the efficiency of those tasks because humans, as we know, we are prone to error most times. But with machines and with automation, you can have precise movement, precise cutting, precise, everything can be precision based compared to where you have a lot of human intervention. So the control system basics. So the basics of control system, we have basically two types of control system as we in generally. So we have the open loop control system, we have the closed loop control system. So by this side here, there's you can see the top part, the top image is speaking to control system that is open loop, that's not closed loop. So this type of control system is just input and output. You feed in an input and then the controller gives you an output. But in this closed loop system, the input is fed into a controller, then from the controller to the plant, from the plant there is a feedback, from the output there is a feedback mechanism going back to going back to a comparator that now compares the output and the input. So if there is a difference between them, it now adjusts the input so that the output can be as close as possible to the input. That's what this closed loop is talking about. So in reality, most times that those feedback elements are usually sensors. Sensors are devices that monitor um, they are devices that monitor parameters, different type of parameters. Then so types of automation. So there's fixed automation, for example, assembly lines. Those ones are fixed permanently. They don't change them that much. There's programmable automation. Those ones are like CNC machines, computer numeric control, that they use for precision cutting, maybe cutting of some gear shaft that needs precise movement. So you have to program the CNC machine to give those precise movement. Then there's the flexible automation. This one deals with robots. So those robots, they have flexible hands, they can move, they can do a lot of things. So we move on to the components of an automation system. And so at this level, parts of the components that we'll be dealing with are the push buttons. So are the switches, and then under switches we have various types of switches. We have the push buttons. So under push buttons we have different types of push buttons. We have the dual push button. That's the type that has both um that dual push button has both a start and stop button together on the same. It has both start and stop push buttons together on the same push button. So it's something like this. It has both dual, both the top, both the start and the stop are together. They're included together. And then we have the push to stay. So there's the type that you push and then it will just stay permanently. Then we have the tactile push button. So there's the type that when you push it, it returns. That's this type, and that's what we'll be using in the practical classes. So these types, when you push them in, there's a spring that pushes the button out again. So it does not hold to stay. Once you push it, it goes in and comes out. Then we have float switches. So float switches are also mechanical switches, but they are used mainly for fluid, liquid, like water. For example, in the practical class, we are going to be looking at automating a tank. So once your tank is full, the pumping machine cuts off immediately. Once the tank level comes down, the pumping machine starts again. So this is the device that will enable us to achieve that automation at a specific water level. The, the the water starts pumping. At another level, it stops pumping. So this flow switch enables us achieve that particular functionality, and it has like a ball inside it and a spring, a ball that moves. So that ball, now when the water level is high, the ball moves to either close or open a contact depending on the mode you are using it in. So and then another concept that you need to understand in automation is the concept of relay logic. So in relay logic we have normally close and normally open. So normally close is a normally close, like your light switch when it's on permanently. For example, this start push button is a normally closed switch. It's always closed, but when you press it, it becomes open. This stop push button rather, is always closed. When you press it, it becomes open. So it opens the circuit and all the other components are de-energized. But for the start button is a normally open NC, normally open, sorry, NO, normally open push button. So when you press it in, it closes the circuit. So that's another concept you should understand going into the whole automation world. You need to really understand the concept of normally close and normally open so that you can know how to apply your devices. Like this float switch now, it has three wires here. So one of the wire is for common, the other one is for the normally open function, the other one is for the normally close function. That's how it works. Similarly, this push button, the stop push button, is a normally closed switch. When you press it, it opens. The start push button is a normally open switch. When you press it, it closes. So another type of mechanical switch that we have is the limit switch. The limit switch is used to limit the movement of an object. Let's say you don't want a door to open to a particular level. So once that door is open to that particular point, this switch either closes or opens, and then it triggers the controller to perform a particular task or maybe to sound an alarm. You want that when they open your door in your house, an alarm will start ringing. This is where you can use a limit switch, or in more advanced settings you can use a other sensors, maybe like the PIR sensor, the passive infrared sensor, to detect motion. So other components of the automation system are electromagnetic switches. So the basic electromagnetic switches we have are relays and contactors, while they are solenoids too, but they also have similar function as the um relay and contactor. So their basic functionality is that once power enters into the coil is energized, and an electromagnetic field is formed, and that electromagnetic field causes a contact to either open or close, to either make or break. So the difference between a relay and a contactor is that relays are used mainly for low power switching mainly, but the basic principle between a relay and a contactor are basically the same. They are electromagnetic switches. So once the coil is powered, in a contactor the coil is usually powered through the A1 and A2 terminal. This is the A1 terminal here, this is the A2 terminal here. It can vary depending on the type of contactor. Then for the relay, you have to look at the back and look at the diagram of the relay to really know how it should be connected. Then this is another type of relay, the DC relay. These types are used for DC application majorly. So they have 2 points. These two points to the left, two connections to the left, are usually for the power. Then the other side is usually for the control. So once you power the coil of the relay using these two contacts, the relay is energized. And as I mentioned earlier, depending on the configuration, either it's a normally closed relay or a normally closed um contact that you are using. Depending on the contact you use, either normally closed or normally open, it will perform different function. So if it's a normally closed contact, when the relay is energized, the normally closed contact becomes open. Normally is closed, but when energized it becomes open. Normally open contact, when it is when the coil is energized, when power enters the relay, the normally open contact becomes closed, and then it closes the circuit. So like I mentioned earlier, the major difference between a relay and a contactor is their power capability. And most times contactors are used majorly for three-phase applications too, compared to the relay. So other components of the an automation system are the sensors. So the sensors are devices measure that measure physical quantities and convert them to electrical signal. Like I mentioned earlier in our introduction to control, we saw the different types of um control systems, the closed loop and the open loop. So the sensors are mainly used for closed loop systems, where you need to get feedback of your process. Like let's say you have a tank. I will still go back to the example of the tank. Once the tank is full, the sensor sends signal to the control system that the tank is full, and then it cuts off. So we have different type of sensors. We have the proximity sensor. The proximity sensor is used to measure distance, proximity, the distance between two particular points. And for proximity sensor, we have basically two types. We have no we have yeah In terms of sensing medium, we have two types. We have the capacitive and the inductive. So the capacitive is used to sense non-metallic objects that have high permittivity value, or that are capacitive in nature. We use it to measure to detect those devices. Maybe like a paper, a plastic cup. That's what we use the capacitive sensor to do. Capacitive proximity sensor to sense. So once the paper gets to that point, it senses the presence of the paper and it sends a signal to the controller. Then we have the temperature sensor. So okay, sorry, the second type is the inductive. The inductive is used to sense metallic objects, any object that has metal in it. So it works like an inductor. Then it induces when it senses that presence of an object that reduces the magnetic field it's emitting. It sends a signal to the controller, either to take an action or then there are other types depending on the configuration. There are PNPs, there are NPN. So and you can also say they are syncing and sourcing, but that's for like advanced level of automation. But basically they are capacitive and inductive. Then we have the photocells for lighting circuits. So when the light is bright, it detects. When the light is dim, it detects. You can use it to control the lighting, the security lighting in your premises. When the sunlight is high, it detects and then it turn on the light. When the sunlight is low, it detects the intensity level, and then when the sunlight is low, it turn on your light at your security light. When the intensity of the light is high, it does not allow your light to come up. Then we have pressure sensors. This one they use it to measure um pressure. Like I said, sensors convert physical quantities like temperature, pressure, distance to electrical signals that are measurable, and most of them give outputs in form of um current, 0 to 12 milliamps depending on the type of sensor. Then we have temperature sensors. So these ones, as their name imply, they measure temperature. Then other components of an automation system are the timers. So the timers are used to perform timing function. So maybe you want an action, for example like your stabilizer or your automatic voltage regulator. Once you turn it on, if the on delay timer functionality is set on, is selected, the your stabilizer does not give output until the countdown of that timer. So similarly, timers can perform similar functions too in automation system. So for example, you don't want your water pump to start pumping after you want it to start pumping after a particular count. Let's say after 10 minutes, after 5 minutes. Maybe like in a dosing pump where you are dosing a particular chemical. You want the chemical to be dosing every 5 minutes. Every 5 minutes, you will use an on delay timer to perform that functionality. After 5 minutes, it dose, and for a period of time it stops. It dose, it stops, it dose, it stops. So it has two functionalities mainly, the on delay and the off delay. So the timing functions after energizing for on delay, while for off delay the timing functions after de-energizing. So these timers too have coils like our relays and contactors, mostly A1 and A2 too for the wiring part. So you connect either your AC source or your DC source to the coil of the timer A1 or A2. So for on delay, after it's energized, that after the coil is energized, that is when it starts counting its on delay functionality. Then for off delay, after the the coil is de-energized, that's when it starts counting the off delay. So there are timers that have both functionalities, both on and off delay. So you can set it. For example, this timer is a more modern and advanced timer, but this one is still being used and is still relevant, but it's more of an outdated timer. So we have other types of timers, the dashboard, the mechanical timer, the thermal. This one works with temperature. So other components of the automation system are actuators. So actuators are output devices that carry out physical task like movement, rotation. Those are actuators. So the types of actuators, the common types of actuators we have are electric motors. This one is a bit popular. They still work in the principle of electromagnetic devices. So you don't want your motor to rotate all the time. That's where automation comes into play. You want it to rotate at a particular time. So you can incorporate your timer, your contactor, you can use your relays, other devices to control when your electric motor rotates. Then your solenoid valve is used, this one is used to control air. So this is the coil. This other black head by the right is the coil. Once this coil is energized, these holes here will either open or close so that air can pass through it. So that air now is used to control a pneumatic cylinder. This is the pneumatic cylinder by your left, by your top left, the pneumatic cylinder. So the pneumatic cylinder move, it's like an arm, it move. So in some robots, they either use a motor, a stepper motor, or in some places that they need more force or more pressure, they can use a cylinder, a hydraulic cylinder or a pneumatic cylinder. Even in some devices like the caterpillars and the likes, they make use of this hydraulic cylinder. So in that case, they have an hydraulic pump that pumps oil. In the case of the pneumatic cylinder, it's air that is being pumped. In the case of the hydraulic cylinder, it's oil that is being pumped. So the oil pushes the piston to move. So that's another component of an automation system. So we have another component are the controllers. So the controllers are used to manage the behaviors of system. They are used to design output by assigning inputs based on feedback. Like we saw in our initial um our first slide, we saw that their controller they for every control system, not all control systems, some control systems are like relay logic control systems um don't require controllers. You can manipulate your relays, your contactors, and your timers to perform the work that the controller should have performed. So the controllers basically receive input from the sensors and give output from the sensors or some switches and give output based on the program that has been sent into them. So we have different types. We have PLC, programming logic controller. We have DCS, distributed control system. We have microcontroller. Microcontroller is like this diagram here of an Arduino Uno. Is a microcontroller. Then we have embedded systems. So embedded systems combines multiple microcontrollers to make up the entire system. Maybe like in your car dashboard control system, there will be a lot of microcontrollers used. So we term it as embedded system. But when you are using a singular microcontroller, it's just a microcontroller. So the symbols used in control diagrams, some of the symbols, like I mentioned before, if you see a symbol like this with an open contact like this, is referring to a normally open contact. On the right here, a symbol like this is referring to a normally closed contact. So but for these ones are for switch, this one is for an isolator, this is for a circuit breaker, this is for a switch disconnect. Then this is for a relay, single pole single throw. This is for another relay, single pole double throw. So it has just one common, but it has two. Either of them can be normally closed or normally open. This one is a double pole with double throw. So like the likes, this is for a circuit breaker, a thermal switch. Then we have manual switch too. You see the symbols, so you can just study these symbols and understand them, so that when you see them in a circuit diagram, you can easily interpret the circuit diagram. Because the first step of understanding a circuit diagram in automation is to know the symbols. If you see a symbol that is, this is a limit switch, normally open, NO. This is another limit switch, normally closed, NC. So going forward, we have design designing a simple circuit. So an example of designing a simple circuit is start start stop motor control using relays. So from on the right here, you have the stop push button. Here, as we mentioned earlier, this is The control circuit is usually made up of two parts: the the control side and the power side. So the control side would usually involve a single phase, like the live and the neutral. So the live part of the circuit enters from here, the top of the circuit. It enters from the stop button. Like I said earlier, the stop button is a normally closed button. Then it goes to the start button. The start button is a normally open button. Then we have the relay coil. This is the symbol for relay coil. Then we have an overload switch. So this overload contact is used to protect the electric motor. Is used to protect the electric motor from damage. So once the overload circuit is triggered, this is a normally closed overload contact. The overload contact opens immediately, and then this circuit is no longer, the path of this circuit is no longer complete. Like I said, we have the live part flowing to the neutral part. So this other part is a normally open contact of the contactor. It is used to perform a latching or a holding function. Since we are not using a push to stay push button, when you press this start button, it goes back to its original position, meaning that the circuit will now be de-energized. But since we have this latching contact, once you press the start button, it energizes the relay, and it's a normally open contact. So as I said earlier, once a normally closed contact, once the relay or the contactor is energized, the normally closed contact becomes, the normally open contact becomes closed, while the normally closed contact becomes open. So they just switch roles. So this relay now, or this contactor contact, is a normally open contact. So once this coil is energized, this contact becomes closed permanently. So it continues the flow of the circuit to the coil of the contactor. So our circuit stays on until this stop button is pressed to break the circuit. So the live current can no longer flow through the circuit again. And vice versa, when you want to start your electric motor, you press the start button again. So this is the, coming downwards, you have the power side of the circuit. So the power side involves three phase. Since it's a three-phase electric motor, if it's a single phase electric motor, it will just involve the live and neutral. But the control part is usually live and neutral, single phase, or it could be DC, direct current, positive and negative. So the positive is entering from the top, while it's grounded by the negative. The circuit is completed by the negative at the other end. So the live flows tries to flow into the electric motor, but the contacts of the relay